7 tool heads, 7 major setbacks, and about 7 different moments where I nearly quit.
No.
About a year and a half ago, myself and a few friends set out on an incredibly ambitious mission to build the world's first open source 7 tool changer based on the Sovol SV08. We were scrappy, plucky, and so incredibly naive. So in this video, I'm going to share the 7 biggest challenges that we've had to overcome to get to where we are today. I'll share what we did wrong, how we fixed it, and most importantly, 10 very, very hard-won and hopefully universally applicable lessons that will save you from all of these headaches on your next project or build. Oh, and stick around to the end, because after all that negativity and pain, I'm gonna end the video on a major high note that you're not gonna wanna miss. Hopefully.
It was very short-lived.
I think.
Celebration time is over.
Let's get after it. The first issue we had to deal with was the length of the belt. See, the Sovol SV08 is a little bit unique in that the belts are held on with a bracket on the outsides of the carrier. Rather than waiting for new belts, I tried to make it work by clamping the belts tightly to the carriage, but I white-knuckled it so hard that I broke the screws in not one.
I'm really hamming this thing, trying to get them in. Oh, I think I just broke a screw in the rail. That's lovely. No.
But 2 different separate carriages. So now I had the pleasure of ordering not just new belts, but new rails as well. This video won't get into all the different technicals so much, but I just wanted to share that because in hindsight, and this is our first universally applicable lesson to take note of, if I were to do this again, I now know that it would have been so much easier to just replace the belts with longer ones. Plus, had I known how many times we were going to need to reprint and change the shuttle and the linear rails, or what a pain in the butt it is to stretch and tension the belts and get them to actually stay put, I also would have just done my research and found the belt holder that the Draft Shift team has since published, which holds the belt in place for you at the expense of about 5 millimeters of Y travel, but it's worth it, trust me. On the bright side, while we were replacing the belts, which I'm pretty sure we ended up doing at least twice because I actually bought belts that were still too short, we took the opportunity to upgrade also the motor and the idler mounts to these super nice CNC versions that CN3D and Physec co-developed, and I'll leave a link to those in the description for those of you who are interested. We also took this opportunity to create some custom end stop holders for the X and Y end stops because we just weren't sure if the sensorless homing on the SV08 would be reliable enough when it came to docking and undocking. Now, we just had to wait for the new linear rail to make it through customs, which, given where I live, took weeks. Once the new linear rail and carriage came in, thank you, by the way, LDO Motors, we installed it and continued assembling the printer, absolutely oblivious to the issue, or honestly issues, lurking under the surface. As you no doubt recall, one of the things that makes this build unique in the first place is the use of 7 tool heads. There are lots of builds out there with 5 or maybe even 6 tool heads, but because this build uses the much slimmer CN3D Spartacus tool head, we believed that with some tweaking, the frame of the SV08 or even the Voron 2.4 could actually fit 7. But what we failed to consider was that the X gantry's linear rail couldn't. It's designed for an X movement range of 350 millimeters, give or take, which is the same as the build plate. But as you can see, the 1st and 7th tool each actually sit about 10 millimeters past the build plate. In other words, we needed to go extra wide if we wanted to be able to put them back. Needless to say, that meant ordering a 40 centimeter linear rail, and when that came in, we promptly realized that it was still just 11 millimeters too short. Story of my life. I then ordered a 45 centimeter rail and cut it down to 41.1 centimeters, just long enough to fit in between the CNC'd parts, only to realize that now the carrier on the new rail wasn't the right size. But fortunately, we were able to swap it with a carriage from the LDO 35 millimeter one that was too short to actually use. So silver linings, I suppose. Still, all this replacing and customizing the rail was just extra work extra expense and a lot of extra delay for an extra tool that, let's be honest, wasn't all that necessary. I would have been just fine with 5 or maybe 6 tools. In any case, there is a lesson here and it's a clear one. If you're planning on building a tool changer, plan your build according to the actual travel range of your printer, not how many you think you can stuff into the frame. It sounds so obvious now, like many of these lessons, but as you'll see, this was just one of many oh snap moments that we had throughout this process, and why I genuinely felt obligated to make this video for all of you. While that longer rail was on order, we decided to proceed with as much of the build as we could. Nadir had actually flown in from Romania to visit for 4 days, and we had planned to finish the printer in that time frame. Unfortunately, by the time he left, we were actually further back than we had been when he'd arrived. It is now 5 minutes till end of business on the last official work day of the week. Nadir is here. We're almost back to the point that we were at before Nadir came. Basically, the issue was that once the assembled tool heads sat on the docks, they were just way too loose and wobbly, and they would almost certainly fall off with the normal vibrations of the printer. Now, there were a number of culprits at play here. There was the weight of the cables, the balance of the tool head design, the angle of the dock, which tilted slightly back, but above all, there just wasn't enough magnetic attraction between the low-quality steel alloy of the screws we used on the tool head face and the magnets that I'd ordered, which were N35 instead of N52. It seems ridiculous, but this one oopsie ended up causing all sorts of problems down the line. So, lesson learned. High-quality hardware is absolutely worth it. And that's not the only lesson that we would gain from this experience, because in retrospect, we should have just hit pause at this point, ordered the right magnets and higher quality steel screws, and then just waited patiently. But because we wanted to make the most of Nadir's time while he was here, that is unfortunately not what we did. Now, we considered various options for fixing it with the tools and hardware that we had on hand. We knew we would need to add some kind of cable strain relief strip like the Prusa XL to reduce the weight of the cable on the back of the tool head, but that wouldn't be enough by itself. And honestly, with this particular design and the sheer amount of junk in the trunk, we even doubted if stronger magnets would cut it at all. So in the end, Nadir and Christian at CN3D decided to modify the design. They chose to add a custom mount on either side to fix the angle of the docks, but more importantly, they opted to add a mating pin and a bushing on one side of each tool and a magnet on the other, partly, again, because we just didn't have enough of those high-quality N52 magnets on hand to do a magnet on both sides. And, like I alluded, this decision would have ramifications that would come back to bite us later on, when we got to the part where we actually docked and undocked the tools. But for now, this meant literally reprinting, like, a lot. We'd have to reprint the docks, the mount, and the faceplates of all 7 tool heads at least once each. Fuck! And by now, we had also nearly run out of the Polymaker Galaxy Gray ABS that we used for the entire rest of the project. So I stepped in and I decided that we would instead print the rainbow, using different colors of Polymaker's ASA and ABS for each dock and tool face. Now this, interestingly enough, turned out to be a great decision, because throughout the configuration process, it would otherwise have been quite confusing to know which tool is which. In case you don't know, because of like computer reasons, the first tool head is actually configured in the software as tool 0, so it gets a bit confusing to remember which number corresponds to which physical tool. It's much easier to refer to them as red or orange, especially when you're working with other people, and especially when you're doing it through video calls and accessing the printer remotely from Tel Aviv, Jerusalem, and Romania. So shout out to channel sponsor Octo Everywhere for actually making it possible for the 3 of us to configure and test the printer remotely as if we were working side by side. Now, fortunately for me, Nadir, who can assemble these tool heads way faster than me, was in town, and he was kind enough to do a lot of the assembly work on these, staying late at the shop and actually live streaming even when I had to run home and attend to family stuff. But still, I do have to admit that when Nadir left, I was pretty frustrated. All three of us had invested so much time and so much money flying him out, taking time away from our young families, and working nonstop for nearly a week. And don't get me wrong, we had an absolute blast together. But as I sat there and I looked at the printer the day he left, I realized that we basically made negative progress. We're still not back to where we were.
Listen, you gotta focus on them.
Gotta focus on the positives. There aren't many, but you gotta focus on them. And yet, somehow, we pressed on. I ordered more parts, and once they arrived, I spent the better part of 2 days while my staff was on Christmas break, assembling the rest of the tool heads, wiring things up again, blah, 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 blah. I also took some time to print some nylon strain relief type things on the Sovol SV08 Max, and they turned out absolutely beautifully, which honestly is a credit to Magigoo PA because I never thought that a printer this big would print nylon. But alas, we weren't out of the woods yet, because once the new tools and docks were printed and assembled, it was time to start calibrating them and testing the docking and undocking action. And here, somewhat predictably at this point, we ran into issues. The way that the Stealth Changer design originally works, the tools level and probe by slightly lifting off of the shuttle, causing a tap sensor in the rear of the backplate to be triggered. Now this means that in order to function properly, the tools need to slide up and down freely using their own weight and a little bit of assistance from the embedded magnets to drop back down. My backplates, however, were not sliding smoothly. They were binding. But because I apparently still hadn't learned lesson number 2 well enough, I didn't know about the newly created Stealth Changer troubleshooting page. If I did, I would have discovered a variety of methods to get things into proper alignment issues. It turns out that this is actually a common issue, and it can be resolved by something as simple as just heat treating the parts to get them to settle into one another. But given the level of frustration at this point in the build, which also, by the way, explains why there isn't so much B-roll for a lot of this, I decided to just crack out the Dremel tool and began shaving down both the bushings and the pins. Eventually, this got the job done, but I definitely don't recommend it. And you'll see why in just a minute. At this point in the video, you're probably thinking to yourself, this project sounds like a nightmare. Why would anyone want to do this? And first of all, yes. So please like and subscribe so that the algorithm will make all of our pain and suffering somehow worth it. But second of all, if you want to build your own tool changer, I want to let you know that you actually don't need to go through all this. And that's because since we started this project, this video's sponsor, LDO Motors, has released a proper, professionally made Stealth Changer kit. Like all of LDO's products, from their Voron kits to their box turtle kits and more, this kit features the highest quality components, from the easy-to-use Nighthawk USB toolboard to professionally made CNC shuttles and backplates. You can even purchase entire toolhead kits for popular toolhead designs like the Jabberwocky or the Stealth Changer, and much, much more to take the hassles out of sourcing your own parts for the toolheads. Plus, when you purchase any open source product from LDO Motors, a portion of the proceeds go back towards the developers of the project to support future development. So take the guesswork and the suffering out of your next open source 3D printer build or upgrade by picking up a kit from LDO Motors. I'll go ahead and leave links in the description to some of their fine retailers all over the world, and thanks again to LDO Motors for making this build possible. All right, let's get back to the video. Now you might think that after all this struggling and all these setbacks and all these screw-ups, it was time for us to catch a break, right? Right? Wrong. The next thing to go was the cheapo AliExpress USB splitter that we were using to split the USB signal to the tool heads. See, because we just had to be gosh darned individuals and do 7 tools instead of 6, the common off-the-shelf solutions out there, like the Bird's Nest or LDO's Nighthawk Hexa splitter, just wouldn't work for our particular application. So instead, we daisy-chained a bunch of the included LDO USB power/data splitter boards for the power part, and then we connected those to a run-of-the-mill USB hub. And that was all fine and dandy. I mean, it worked great, but in order to get it mounted cleanly under the printer, we decided to remove the housing from it. Now, unfortunately, the manufacturer of this particular hub never intended for someone to do that, and they were clearly counting on the plastic housing to support the USB input port. So in all the jostling and moving around and flipping the printer upside down to work on it, that connector snapped right off the board. And I assume that even if I hadn't broken it during the build, the daily vibrations of the printer coupled with the weight of a cable dangling in a way that it was clearly never intended to would have eventually destroyed this thing anyways. Fortunately, I did have a couple of 4-to-1 USB hubs that we were able to chain together, but those might actually be causing some of the communication issues that we're currently seeing. So the lesson here is to either use a solution made for the purpose of 3D printers, such as LDO's Nighthawk Hexa splitter, or if you are going to use something meant for a normal computer, maybe don't hack it to pieces in a way that compromises its strength. Now surely, after all of this, it would be good, right? If only. Remember how I said earlier on that adding those pins to the dock would come back to haunt us later? Well, this is that later. Basically, the pin solution was great in that it held the tool on the dock nicely and there was no way it could fall off. The problem was that also meant that we'd need to raise each tool by an extra 10 to 12 millimeters on each docking and undocking operation. And it was only when we went to actually program the docking and undocking macros that it hit us, both literally and figuratively. That extra 10 to 12 millimeters would cause the belts to snag on the PCB of each tool head. Come on. And we could trace the entire issue back to one decision. The decision to modify the design rather than wait patiently for higher quality screws and magnets. Another costly lesson. So by now, we were really running out of steam. And again, I apologize that I just didn't have the will to turn on the camera and record so much of this. But you have to understand, it had been months and months of waiting for parts, printing and reprinting, assembling, disassembling, and reassembling. So for now, the solution that we've come up for this one is to just shave down the pins and swap out the magnets on the dock for the stronger N52 ones, which have since arrived. Now we still have 5 to 6 millimeters worth of pin to help keep the tool mounted, but it's not as infallible as the full 12 millimeters was. And it's also super tight, like really, really, really tight, to the point that I'm really worried about the printer breaking either the PCB or the bushing if one of the tools isn't perfectly seated. Now I might experiment with just gluing magnets in place where the bushings and the pins are now that we have the stronger ones, but either way, there is absolutely no way that I'm reprinting and reassembling all of the tool heads. Well, at least not all of them. More on that in a second. Here, again, this was a mistake that bore two lessons that now seem obvious in hindsight. Before modifying a design, and certainly before printing and assembling it out 7 times, start with printing out 1 and then rigorously test the clearances in action. Test how that design will impact docking and undocking, homing and motion, rather than simply focusing on the stationary performance. Or again, just stay with the mainline version of whatever it is you're building, or at least wait until we finish, test, and publish this one. Honestly, this one is totally on us. It's a classic case of go slow if you want to go fast. As you can probably imagine, and I know that I've said this a few times throughout the video, at this point, team morale was at almost absolute zero. Not only were there just so many setbacks, but it's also hard to deny that since we started this project, some very cool off-the-shelf printers and products have come out that have made us question if this was worth all the effort. So I'll admit that I was already starting to ask Nadir and Jacques if we should just cut our losses by the time we'd hit our next major hurdle. All of a sudden, for no reason, the tool heads got super loosey-goosey. They were wiggling so badly that we couldn't even get an accurate quad gantry level. Up until this point, Nadir had remained an absolute paragon of optimism and enthusiasm when it comes to this project, but this finally broke the smile on his face. Had my impatience and dremeling rather than finding a real solution ruined all of our work? Were we back at square one? And of course, the question that we were all afraid to ask ourselves: had we bitten off more than we could chew with this build? We decided to break for the day and head home. And for probably the 7th time over the last year, I seriously considered just throwing in the towel. But there were a few reasons that I didn't. First of all, obligations. Not just to sponsors or to Nadir and Christian of CN3D, but to all of you. I know that for some reason, you guys are still interested in this project and you continue to ask me about it in the comments of nearly every video. Plus, that night, when I went home and told my 5-year-old why daddy had had such a hard day, the kid sucker punched me with a, "But Abba, I thought you told me we don't give up." Woof. So I guess we're doing this. Second, I remembered the real reason that I embarked on this project. Views. Wait, no. I mean, not entirely. The satisfaction of building something yourself. Like, my Voron 2.4 isn't my fastest printer, or even my most capable. And yet, because I built it by myself with some help from my father and my son, I love that thing way more than any normal printer. Its value far exceeds its practical use. I'm proud of it. I built that thing. So yeah, I know that this tool changer probably won't compete with store-bought, mass-produced solutions like the Prusa XL or the Snapmaker U1. But that's not the point. At least, that's what I've decided to tell myself. The point is the pride of building something special. Also, without this project and the countless hours of banding together to solve problems, I wouldn't have met two people that have become like brothers to me. It's super corny, the whole friends we made along the way thing, but it is a cliche for a reason. Oh, and that issue with the wobbly tools? Yeah, one of the bushings of the carrier had just been pulled out, but we were just too tired and burnt out to notice it the night before. And that's both our last lesson and a cautionary tale. If you take on a project like this, you kind of just have to accept that it is a massive undertaking, and it's going to take much more time than you think. There will be frustrations and setbacks, and you just have to know when it's time to walk away for a day, a week, or even a month and come back fresh. There have been literal months at a time where the team and I just took a break and allowed our motivation to replenish. There's no shame in that, unless, as my little boy reminded me, you don't come back. So where do we stand now? Does it print? Well, kinda. Maybe by the end of this video. As I record this, we have most of the tool heads rebuilt, and I am in the process of shaving down the pins so that we can dial in the exact positions and docking and undocking macros. Unfortunately, as you might recall, I was impatient at the start of the build, and I insisted that Jason at LDO Motors send me some of the reject pre-production versions of the Nighthawk boards rather than wait for them to manufacture a new batch. Because get this, I didn't want the project to get delayed. In any case, he was 100% right about them not being up to spec, and they are slowly burning out one by one. So in the end, I will need to end up replacing them with a few of the production versions, which should be in the mail as I'm recording this. So yeah, in the end, I will be rebuilding the back half of at least 2 or 3 of these yet again. But as of right now, at least the printer moves, it homes, it does quad gantry leveling and bed meshing all perfectly. And additionally, we, namely Jacques, are working through all the funky clipper configuration stuff that comes with having 7 tool heads.
The drive, the determination. Ladies and gentlemen, Jacques is available for hire. He is looking for an interesting opportunity in software development. Jacques, give us a smile.
And I can't tell you how much time we wasted just trying to figure out why the printer would level, heat up, and then do absolutely nothing, simply because not all of the tools were heated up.
Attempt number 677 failed.
It's all very confusing stuff. I'm very grateful to have Jacques on it, but I also promised you guys that I'd try to end this video on a high note. So let's go ahead and hit pause, check in with editing Jonathan, and see how things have been going since I recorded this. Johnny boy?
Are we printing with 2 tool heads?
Coming out.
Don't tell me. Was it good? God, I hope it was good. Those poor sons of biscuits really deserve a win already. Either way, by the next video, we intend to have this thing actually printing properly with all 7 tool heads. There's a lot more work left to be done, of course. We need to get all the tools lined up. We need to perfect docking and undocking. We need to build the enclosure and much, much more, because I'm also planning to upgrade the printer with the open source iHeater chamber heater so that it can print some very, very exotic materials on it. So do get subscribed if any of that is of interest to you. But also, I'd love it if you dropped a comment down below and let me know what all of you would like to know about this build in the finale, because a tour of the finished printer probably isn't going to be all that interesting. Or is it? I don't even know anymore. Until then, let me once again thank all of the companies who have helped make this build possible, especially LDO Motors and Sovol, who have supported it financially. Oh, and a huge thanks to all of you for watching. You guys are literally the main thing keeping us going when things get tough, and they've gotten tough a lot.
That's all for this week. See you all of you at the next layer.
Close enough.
We set out on a mission, feeling clever, feeling bold. A 7-tool Sovol that would truly break the mold. We were scrappy, we were plucky, we were sure we'd be fine. Then I gorilla tightened belts and snap screws 2 times. Oh, the rail was short by centimeters, just a casual little sin. So I ordered 1, then 2, then 3, and still couldn't win. 4 weeks the counter shouted like a cruel arcade, while customs laughed politely and my sanity decayed. The docks were kinda wobbly, the magnets were a joke. Crappy steel alloy screws, yeah, that's how heroes joke. So we printed 7 colors like a tactical parade, because too little was too one and my brain was getting frayed. Then the shuttle started binding, so I grabbed the Dremel, yikes, shaved a little here and there like precision in my psyche. And the USB hub would snap when I took the case away. Turns out naked PCB chick is not the move, okay. Now the pins were tall and proud, 12 millimeters of spite. So the belts went kissing PCBs in the dead of night. Motivation hit 0, I said we're done, I quit. Then my kid goes, ah, but you said we don't give up. Well, shit.